An electron is accelerated from rest through a potential difference of v volt. If the de Broglie wavelength of the electron is 1.227 into 10 to the power minus 2 nanometers, you have to find the potential difference. So if the potential difference is given, the formula of de Broglie's wavelength is lambda equal to 12.27 over root of the potential difference in terms of Armstrong. So we'll convert everything into meter. 12.27 upon root b into 10 to the power minus 10 equals our given wavelength in nanometer, which is 1.227 into 10 to the power minus 2, converting it into meter into 10 to the power minus 9, because 1 nanometer is equal to 10 to the power minus 9 meters. On our left hand side, we'll shift the decimal, so into 10, 10 to the power minus 9 over here, 1.227, 1.227 cancel, and so do these terms. We are left with 1 by root b is equal to 1 by 100. So v is equal to 10 to the power 4 volts. So our potential difference is option 2.